Good morning. So I sort of wanted to take some time document my object loader that I wrote this semester for computer graphics, particularly because I'll probably be extending this in the future, and yeah, more than likely I'll be reusing the base of this project for final year. So it's best to get it documented, and of course might help some of you as well. If you want to write your own object loader or just straight up copy this one, it's fine as long as you reference, it's okie dokie. So it's about 60 lines of code, extremely simple. And so let's just start off at the very beginning. So the function signature is a boolean, right? It's called load object, and it's taking in some path to your object file, and then it's taking in a reference, right, to some structure. So I have some notes here that I sort of rewritten so I don't have to write it on the fly. I think that's what takes up a lot of time. So this is the name of the structure, obj mesh, and it's first off an array of floats and just an integer. So that's the components inside of the structure. And you should know as well then, if you have an array, right, all you have really is a reference to the first element inside of that array. And since it's in a contiguous block, you can just do pointer arithmetic to progress down your array. So this is all the obj mesh structure is. Oh, by the way, if you've noticed an improvement in the audio quality, you should thank the guy that came into my chat this morning, sort of left a comment telling me about noise suppression and OBS Studio. So I think I'll be using this from now on. It's certainly a big improvement over a simple screen recorder. So we've got a lot of rich functionality. So okay, and alright, then we've got a file pointer here, right? It's called f, and we've got three vectors: position, norm, right, and output. Okay, so position is going to look something like this. We have x1, x1, y1, z1, and I think I should show you first of all what an object file looks like. So I have a very simple example. It could be helpful. Tests, yeah. So this is what an object file would typically look like. So for a single triangle, right, you have v, which just means the vertex, right? And so what position is the vertex in space? And then you have a vertex normal. So this is just a comment, by the way, I just commented these out. So you have vertex normal. And so which direction are the vertices facing it, right? So yeah, it's pretty straightforward. Nothing too complicated there. And then finally we've got a face. What the face does is sort of relate the vertices together. So you should know if you've got like three vertices together, you've got a polygon, that's a triangle, right? So what this is saying is, right, group the first vertex, this one, with the first normal, right? Group the second vertex with the first normal again. So all of them are pointing in the same direction in this case. And then group the third vertex with the first normal as well. And that will give you a triangle, right? And I'll show you in the program later on how this actually gets rendered out. Oh, this is the music that I'm playing in case you're wondering. I don't know. I think there's some credit at the bottom here. So the original composition is from Suno AI or Suno Al. I'm assuming that's an Al. Then there's text from some historical sources. I don't know any Chinese, so hopefully you guys can translate that, but this is the source. Maybe I will leave a link to it in the description as well. But this is kind of the equivalent to lo-fi for me nowadays, or lo-fi, however you want to pronounce that. Okay, so let's get back to this. So then, right, we can see then we've got position and then we've got norm. So let's go back to the program to sort of give you an idea of what's going on. So we've got three vectors. Oh, and you should know a vector is sort of just like a dynamic array, right? You can grow the array. So we've got position, norm, and output. Fairly straightforward. So if you want to just say three vector floats, that's fine. We've got an array of characters as well. And what we're going to do, right, is just feed, right, into this array of characters the first line, right, that we get from our fopen function up here. Okay, so you collect the first line from the object file and it goes into this array of characters here. Excuse me, my allergies are starting to act up a bit. So now we're just going to declare three floats, right? And the first thing you do is use scanf, right, to check, right, is this a vertex? If you remember from the test object file here, we've got first the program started with all the vertices, right? Any object file typically will look like this. It's going to start with all the vertices, and then it's going to go to the vertex normals, and then finally it's going to go to the faces. So the first thing we have to do is collect the vertices. And so all we're going to do, right, is check if it starts with V, store the positions, right, the values into X, Y, and Z. Equals tree just means that it returned the proper success code for scanf or scanf. And then we'll use this position.pushback, right? This pushback, you can think of it like a method, really. It's not really a method, it's a method. Think of it like a method, it's fine. And so it's going to grow, right? So the first thing that's going to happen is it's going to put X here, and then it's going to put Y here, and then it's going to put Z here. And this is on the first pass, right? And then the program will, let me just close this off. Then the program will continue and say, okay, well, is it a vertex normal? Is it a face? So we're not concerned with this for now, right? For now, we're just looking at the vertices in isolation, right? And so it'll go through all the vertices first, right? And then it'll come again at the start of the loop, and then it'll check. And it'll pick up the second vertex, right? And it'll put it in here. Same way. Third, fourth, fifth, sixth, all the way down, right? Until it's picked up all the vertices. And then, right, it'll come down and do the same thing for the vertex normals. So you'll see the vertex normals is quite literally just the same syntax, right? So it'll do the same thing for the vertex normal, right? It'll push X, push Y, push Z, and then just push all of the remaining vertex normals that it finds inside of the file. Now, for the faces, how it's constructed is you'll notice that there's a double slash here, right? Let me use a different color. There's a double slash here, and this just separates the vertices from the normals, right? So if you were to imagine a triangle like this, right? Obviously we've got 3 vertices, so this could be like the first vertex, this will be the second vertex, this will be the third vertex, right? And then you need to know which direction each vertex is facing as well. So here you'll just put n1, n2, n3. Or in our example, they all of the vertices were facing in the same direction for the triangle. Okay, so that's fairly straightforward. So what you do, right? So if it's a face, right, you declare 2 integer arrays, right, v3 and n3, right, and you collect or interleave these values in. So if you look here, this value will go into v0. This value will go into n0. Okay, you see that? So this is v and this is n, right, that we've declared in the program. And so v1 will come here, right? v2 will come here. v3 will come in here. And then the normals get stored over here. So the first normal will get put in here. The second normal will get put in here, and the third normal gets put in here. So we've got 2 separate arrays, one that stores the vertices and one that stores the normals. Okay. And now what you have to do is sort of loop over for every vertex, right? And you need a position index and you need a normal index. The reason for this, you can sort of think of it as a stride, and you'll see in a second why this makes sense. But all it's doing is it's going to index, right, the value that we stored. So let's just think of this like logically. On the first iteration of the loop, right, on the first iteration of the loop, I is 0. So it'll go v of 0, right, minus 1. Why the minus 1? Because typically, right, there's a mismatch between the way C or C++ handles indexing and the way object files handle indexing. Object files start counting from 1, right? But we're accustomed in computer science to start counting from 0. And so you need to account for that mismatch by subtracting 1. This actually gave me quite a bit of headache because I was not aware of that fact initially. So again, so v of 0, right, on the first iteration will just be 1, right? So if we think of our triangle example, right, it was 1, right? If you look at this, so v0 here would be 1. So let me just write it out. Let me copy this. And I think I have text. Right. So let me just reconstruct this in a nice way so you can sort of visually follow along. So v, right, would just be 1, 2, 3, right? This is what the scanf is going to do. And then n is just going to be 1, 1, 1, because they all have the same normals, right? So this is what we have inside of each of these arrays, and then it's going to come down. Oh, cancel. Let me just leave it like that. Actually, it's fine. Then it's going to come down here, right, and it'll say position index is equal to v of I, which is 0, right? But v of I is 1, right? But you have to subtract 1, okay? So it'll be 0 times tree. Tree in this particular case you can think of as a stride, right, if you want to. Well, how much you have to jump, and it'll become clear in a second why we need this. And so position index on the first iteration, right, where I equals 0, position index, right, will just be 0. Right, and it'll be the same thing for the normal index as well. Normal index will also be 0. And then what it's going to do is it's going to come down here and start populating our output vector. Okay, so remember we've got our output vector. We'll just say output. And so the first thing it's going to do is it's going to push, right, position, right, and then we're going to index using the position index now. So position index is 0 on the first instance, right? So it's going to take that first element inside of your position vector. Remember, we've got this big long position vector that we built up here at the very start, right? That collected all of the vertices. So it's going to collect X, Y, and Z initially, right? That's what it's going to do here, right? So it's going to go 0, 1, 2. So it's collecting X, Y, and Z. So we'll say, let me use red. So it'll collect X, Y, and Z from the position vector, right? And then it's going to do the same thing as well for the normals. It's going to collect the other normals as well. Right, so the normal index is 0, 1, and 2. And remember, we have a separate vector for the norms, so it's going to collect the norm for X, Y, and Z as well. So let me use black, X, N, Y, and Z. And this is just for the first iteration, so I'm just going to put I equals 0, right? And we'll put a separation here. Now, when I equals 1, what it's going to do is going to come up back here now at the very top, right? So now I is equal to 1. And it's going to do the same thing again. But now, since I is equal to 1, 1 minus 1, right? So I think you can sort of start to see what's happening. In this particular case, so I might be 2, right? So let me see. What is I? Yeah, so I now is 2. So it'll be 2 minus 1, which is just going to be 1, right? And so then it's 1 times tree. So the stride now all of a sudden becomes tree. And it's going to do the same thing for the normal as well. Alright, so the stride is tree, position index is tree, and normal index is tree. So when it comes down here at the bottom, right, it's going to index the position index tree plus 0. So it's going to come up all the way up here. And it's going to say, okay, start collecting from this guy here now, right? Tree plus 0, tree plus 1, tree plus 2. So it's going to collect the first 3 vertices, right? So I hope that's clear. So it'll collect the first 3 vertices like so. And then it'll do the very same thing for the normals as well. Not going to take time going into that. And then when I equals 2, right? Now, what's going to happen is the value itself is going to change, right? I hope you can see what's going on there. So, again, let me just go through. So now that I is equal to 2, right? This guy is 3 up here. Right, so it'll be 3 minus 1, which is 2. Let me just write it. So it'll be 3 minus 1 is equal to 2, right? Times the stride. Right, and so this will give us a total of 6 for our normal. So position index will be 6, and normal index will also be 6. So now, what's going to happen is that when it wants to collect the values, it's going to say, okay, go 1, 2, 3, 4, 5, 6, right? And start collecting from here instead. So 6 plus 0, 6 plus 1, 6 plus 2. And it's going to do the same thing for the normals as well. Right? 6 plus 0, 6 plus 1, 6 plus 2. And it's going to store those values here. Right? And this is what the output is going to look like for a single face, actually. Right? This is what the output looks like for a single face. And so the face has 18 total vertices inside, right? Each face has 18 total vertices inside of it. And so this is actually enough if you just wanted to render out a single triangle, right? Like what we had in our contrived example here. Then what you would do, let me just go back to the program to sort of complete our example, is you just close the file, right? Let's say that's the end of the file. You close the file, right? And then you say, okay, you give the mesh count, get the total number of vertices. And so that will just be the output size divided by 6, casted to an integer, because remember our mesh structure was defined as an integer, right? And for the count of the vertices. So I hope this is clear how we get the number of vertices. You just divide by 6, right? Because remember the output size was 18 in total. So divide by 6, you'll get 3, right? 3 vertices. And the mesh.data, first thing you have to do is allocate size for it, because remember it was a null pointer initially, so we need to set some memory aside for that, right? And so remember it's float though, so size of float, so the output size, right, times size of float, how many in all do we need, and then we cast it to a float, right? So now we have the space for the array, and then we use memory copy function, right, to say, okay, where's the destination? Mesh.data, remember we gave it a reference to a mesh structure. Remember the function is taking in a reference to a mesh structure, so we're taking that reference and we're populating it now with the data, right? So mesh.data is going to get the first output, so a reference to the output vector, right? So the output vector is literally just going to be copied in. All the floats are going to be copied in to mesh.data. And then obviously you need the size as well, which we already have. So, excuse me, it's very simple. My allergies are acting up here on me. So it's very, very simple. Nothing too complicated, I hope. And yeah, so, and then it's just going to repeat this over and over again, no matter how large your file is. And so let's sort of take a very trivial example. Let me go in to my final project. I was hoping to show this in our presentation, but unfortunately we don't have the time, so I'm just going to show you right here. So, oh, let me move the car. And if you notice all the way at the top there's a triangle. Let me drive the car back. I don't have like the proper angles set up for this actually. Okay, yeah, you can sort of see the triangle that we rendered. So this is actually the origin up here. This is the origin. In local coordinate space, when it comes in, this is where the origin would be, right? So let me show you. So the first vertex, right, was at 1, 0, 0. So I need to draw this out on the Cartesian plane. So your first vertex is 1, 0, 0. So it's here, right? This is the first vertex. It's positioned here. And the second vertex is 0, 0, 0 at the origin. So it's here, right? And the third vertex is 0, 1, 0. So it's just 1 up here. So it's going to look like this. And you can see like that's exactly what it looks like, right? So you can actually tell that this is the origin here. This point 0, 0 is the origin. And this here is positive 1, right? And this is up, positive y. So it's very easy. And then I wanted to say, okay, well, what if we wanted to construct a square? You can actually make a square from two, where is it? From two triangles. So instead what you do, and here's the really neat part about these object files, is that you don't need to reuse the vertices, right? Because look at this. If I wanted a square, I would just need another vertex here, right? So I can just put in another vertex and reference all the other vertices that I've already predefined, right? And so this would give us a square, like so. And how would you do this? Well, so first of all, you put in the fourth vertex, which is at 1, 1, 0. So 1 along the x, 1 along the y, none along the 0. So yeah, it's precisely here, right? 1, 1, 0. And then what you do is you have to reference for that face, right? So now what you have is the old triangle, right? Plus now the new triangle is going to be first face, right? First vertex. Well, we didn't label the vertices properly actually, but we can say like this is v1, v2, v3. No, we can't do that. We need to like be very precise in the way in which it was labeled in the file. So 1, 0, 0 is actually v1. This one is v1. 0, 0, 0 is v2. And this is v3. This is how it's being referenced in the file. And then this is v4 here. And so we're gonna use this guy, yes, and we're gonna need the third vertex as well. So yes, you can see here we're saying the third vertex and then the fourth vertex, right? And so that's how we reconstruct this. If I were to save this file, close this and start it back, I don't think I have to, I shouldn't have to recompile. And let me just reverse a bit. There we go. Can you see the square now, right? So this now it went from a triangle to a square. So that's pretty neat, right? And so that kind of gives you an idea now. And then you can, if you wanted to, for our labs, I think we had to make a cube, right? You can just replicate this and just get the cube, right? With the same sort of primitive logic. Okay, and then rotation stuff is fairly simple. I don't know how much of you managed to suffer through, if any of you at all suffered through the horrible audio quality of my derivation for the view and projection matrices, but yeah, I'm not redoing those, unfortunately. That was 2 hours long. It's the audio quality is terrible, but it's good enough if like you're willing to suffer for it. So okay, yeah, so I think I'll wrap things up here, and hopefully the documentation is not too terribly done. So have a good one, guys.